Welcome, student of technology. This is one of my mini reading videos. You might think it's kind of strange I'm creating videos of me reading, but seeing how this is for my auditory students, I want them to be able to see the spelling, see the syntax of the code that we're reading, and be able to pause and take notes if need be, or fast forward through the parts that they already know. Couple reasons there for me to make a video of reading. If you're like me, reading can be really tough, and if you're reading technical documents, that can be especially true. So I suggest the Crazy Professor reading game. If you just YouTube that, you can see some examples. I've used it on occasion when I've had to go through some really dry reading before. Now, if you are a big auditory learner, I suggest the Readable app. I get most of my stuff from Wikipedia. What this app does is searches through Wikipedia articles and it reads it to you. It's done in a computer or robot voice. As long as you don't mind that, you should be fine. I'm sure it's better than listening to my voice, in fact, so definitely check out that app. What I'm doing in class with my reading, the purpose behind it is I'm just trying to inspire discussion. When in class we have a few short paragraphs to read and comment on, and those comments turn into conversations. And those conversations turn into something solid to remember and hopefully help you on the test, hopefully help you remember the content we've gone over in class. So that's the big difference between these videos and what I'm looking for in class. Now, just to wrap up, I want you to know that reading is the #1 indicator of future economic success. It is a big deal. Of all the things you do in school, reading is probably one of the most important ones. And a lot of times it doesn't matter what you're reading, it just matters that you can understand it, especially if you put in enough time and effort. Can you figure out what the text is saying? And I think this is especially true in the tech industry. If you become a programmer, not only are you going to read through code, but you're going to search for answers and you're going to read a lot of non-answers. It's going to take time and you're going to have to, trudge through it. But in the end, just remember these videos aren't a replacement to reading, just a prelude. The title of today's reading is Intro to HTML. Hypertext Markup Language is the standard markup language for creating web pages and web applications. With cascading style sheets and JavaScript, it forms a triad of cornerstone technologies for the World Wide Web. Web browsers receive HTML documents from a web server or from local storage, and you're going to see I highlighted that local storage is typically memory inside the CPU, or local storage could be used to refer to the hard drive. So when a browser, Chrome, Firefox, opens up an HTML document, it's typically getting this from a web server, not from your hard drive. But if you're the one creating the web pages, saving the files as an HTML file, then yeah, it'd be pulling up from your local storage. Or from local storage, and render them into multimedia web pages. Render is what the browser is doing. It is taking the document and turning it into a web page, following the instructions the web creator has specified using HTML. HTML describes the structure of a web page semantically and originally included cues for the appearance of the document. That'll change with CSS. HTML elements are the building blocks of HTML pages. With HTML constructs, images, and other objects, such as interactive forms, may be embedded into the rendered page. So when it says interactive forms, if you're a construction company and somebody visits your web page, they can type in their name and number so the company can get back to them with a quote or whatever. That would be an example of an interactive form. It provides a means to create structured documents by denoting structural semantics for text such as headings, paragraphs, lists, links, quotes, and other items. HTML elements are delineated by tags. This word delineated is kind of like described. So the elements are described by the tags. If you're creating a paragraph-like element, you're using a p tag. So delineated by tags, written using angle brackets. Tags such as img and input introduce content into the page directly. Others, such as p, surround and provide information about document text and may include other tags as sub-elements. Browsers do not display the HTML tags but use them to interpret the content of the page. So in this sense, this markup language is like an interpreted language. HTML can embed programs written in a scripting language such as JavaScript, which affect the behavior and content of the web pages. Inclusion of CSS defines the look and layout of content. So if I was you, I'd write like CSS equals look and layout. The World Wide Web Consortium, maintainer of both the HTML and CSS standards, has encouraged the use of CSS over explicit presentational HTML since 1997. So that kind of answers my question up here when I was wondering what's the date that they stopped using HTML for the look and layout. There's the answer, 1997. Almost done. HTML markup consists of several key components, including those called tags and their attributes, character-based data types, character references, and entity references. HTML tags most commonly come in pairs, like h1 and \h1, although some represent empty elements and so are unpaired. For example, img. You'll see unpaired tags in Module 1 on sololearn.com. The first tag in such a pair is the start tag, and the second is the end tag. We more commonly refer to those as the opening and closing tags. Another important component is the HTML document type declaration, which triggers standards mode rendering. Basically what that paragraph says is when you type this in, the computer knows that you're about to give it some HTML, so then it'll know what to do from there. The following is an example of the classic Hello World program, a common test employed for comparing programming languages, scripting languages, and markup languages. This example was made using 9 lines of code. Maybe I should move it down there so you can see it in its entirety. This is the skeleton. The skeleton of every web page on the internet is right there.